Okay, let's take a look at Chapter 6.7, Similar Figures. Here are the first set of key concepts. Please get these copied into your notes, and when you're ready for the explanation, go ahead and replay me. Okay, so we have corresponding parts of similar figures. Similar figures are figures that have the same shape, but not necessarily the same size. So figure ABCD is similar to figure EFGH. So in symbols in math, we write it as ABCD is similar, that little squiggly line means similar, to EFGH. Now let's look at these little sideways kite-looking things. And this is shape ABCD, and this is shape EFGH. And if we look at these, it kind of looks like this one on the left is a little mini-me of this guy here on the right. So that's really what similar figures are. It's either a little guy or an expanded version of one. And we can think of that kind of in Snicker bars. You have a king-size Snicker bar, or you have a little fun-sized Snicker bar. They're the same shape, right? Same candy bar, but they're not necessarily the same size. That's what similar figures are. So similar figures have corresponding parts. These are angles and sides in the same position. Okay, so angle A corresponds with angle E, and angle B corresponds with angle F, angle D corresponds with angle H, and angle C corresponds with angle G. And then we also have corresponding sides. Let me change colors. AB corresponds with side EF. BC corresponds with side FG. CD corresponds with side GH. And we've got AD over here corresponding with side EH. All right, here's one more set of key concepts. Go ahead and get these copied in, and replay me when you're ready for the explanation. All right, so this is two figures are similar. Then, remember, similar means the same shape, but not necessarily the same size. Think of that fun-sized Snickers bar and a king-size Snickers bar. That means the corresponding angles are congruent, or they have the same measure. So congruent just means same measure. They equal. And the corresponding sides are proportional. So let's look at this triangle ABCD and triangle XYZ. So angle A is congruent. This little symbol here means congruent. That means angle A's measure is equal to angle X's measure. So this A is the exact same as angle X. Similar with angle B is congruent to angle Y. Angle C, shown with 3 lines, is congruent to angle Z. Now, those are the angles. Okay, let's erase those. Now let's look at the sides. The sides are proportional. So let's look at side AB. This side is going to be corresponding with XY, and we can set that as a proportion to be to side BC and YZ. Or we could also set a proportional to AC and XZ. Okay, so all of those sides together are proportional. Okay, so let's look at some examples. So this one is I do. And I want to look at these, and I'm going to find the missing measure. Now, remember what a similar figure talked about. It said that figures are similar. That means they have proportional sides. So I'm going to set up a proportion in order to find this missing measure here. So I want to set up my proportion to be, let's do the small triangle over the big triangle. Okay. Okay, so let's look at this small triangle here of ABC. Now, this side here, AC, is corresponding to this side DF. If you can see the angle of A, it has one arc, and the angle of C has 3 arcs. Now look over here at DF. Do you see that D has 1 arc and F has 3 arcs? That means that those are the same line. So small AC is 4. Big is going to be 12, right? 4 here, 12 here. And I'm going to set that equal to the small of 6 over x. Okay? And then you just solve your proportion. We get 4x equals 72. Divide by 4, and x equals 18. So the side EF is 18 centimeters. Okay, you do this one. Alright, now this one is a little bit tricky because our sides are not exactly lined up. You see, RSTU is a little bit flipped from XY or WXYZ here. So we have almost a mirror image. So we have to make sure that the sides that we set up as a proportion are going to be the corresponding sides. So you want to look at your angles to make sure that you're setting up the exact same sides, the corresponding sides. So let's compare this from big to small. Last time we did small to big, you can do big to small. So let's look at RU here. We've got 28, and I want the side that compares to RU. So I have 3 here with R, and now over here I have W has 3. Then I've got U with this 1 and a slash through it, and Z over here has 1 with a slash through it. So the corresponding side to RU is WZ. So that's 4 equals, we've got this guy here, big, as 49, and my corresponding side to that is D. Now I'm going to solve my proportion here, and I get 28D equals 49 times 4 is 196. Divide by 28, and 196 divided by 28 is 7. So side XW is 7 feet. Okay, I'll do this one. Alright, so we have set up here, these are rectangles, so they're not as tricky as triangles can be, because this long side is going to be corresponding with this long side here. LO is going to correspond to PS. So we're going to do small to big. If you write small to big, it will help you remember what you're comparing. So I'm comparing this small guy of 5 over 30 equals that small guy of B to the big guy of 24. And I'm going to solve that proportion. I'm going to come up here. I'm kind of running out of room. So 5 times 24 is 120 equals 30B. Divide by 30 on both sides. And 120 divided by 30 is 4 equals B. So the side ON is 4 centimeters. Alright, you do this one. This one is a little tough because the triangle is flipped upside down. So you want to make sure that whatever you're comparing the corresponding sides. Okay, they have to have that same side. Alright, so we're going to compare small to big. And I'm going to set up this 4 to this A. Now why did I do that? Well, if you look at this angle G, it only has one little tick, and so does J over here, that one little tick. And then H has two little guys, and so does K. So I know that this JK is corresponding to this GH. So make that set equal to 7 over 14, big to small. Going to solve our proportion here, and 4 times 14 is 56 equals 7 times A, and then divide by 7, and A is 8. So this side JK is 8 centimeters. Alright, so here is a word problem. An architect is designing a decorative window for the entrance of a new office building using similar triangles. If triangle ABC here is similar to triangle DEF here, find the length of the segment DF. We're trying to find this guy here. So we're going to name that X. So we want to set up our proportions. Let's set up the triangles from small to big. And I know this side EF, and I know this side AB. I also know this side DF corresponds with this side AC. So I'm going to set up my proportion knowing all those things. So my small is 9 to my big, here, 18, equals my small of my X over my big 25.5. 25.5. Then we cross multiply here, and we get 9 times 25.5 as 229.5 equals 18x. We divide by 18 on both sides, and we get x to equal 12.75. Now here we want to say the segment DF is 12.75 inches. Okay, now here is an example for you to try, and replay me when you're ready for the explanation. Okay, so this says a rectangular blue tile has a length of 4.25 inches and a width of 6.75 inches. A similar red tile has a length of 12.75 inches. What is the width of the red tile? Okay, so we've got a blue tile and a red tile. And these are similar. Oh, I didn't make those very similar, did I? But you can get the idea. Let's see, this has a length of 4.25 for a blue and a width of 6.75. All right, and over here on the red tile, they have a length of 12.75, and we're trying to find the width. Okay, so we're going to set up a proportion knowing that our length on the blue is 4.25 and our width on the blue is 6.75, and our length of the red is 12.75, and we're trying to find that width. So we're going to compare, let's compare blue to red. Okay, so our blue length is 4.25. Our red length is 12.75. Our blue width is 6.75. And we're trying to find that width. So we do some cross multiplication, and 12.75 times 6.75 is 86.0625. Let me erase that. That's a 6. 86.0625, and then we get 4.25 W. And when we divide 86.0625 by 4.25, we get W to equal 20.25. So the width of the red triangle width is 20.25 inches. Okay, and here is your extra practice, so go ahead and try these as best you can, and we'll go over them the next time we see each other.